Well, I'd like to welcome everybody today to our webinar, The Future of Potato Nematode Management, a Systems Approach. My name is John Lundeen. I work for Potatoes USA, and I've had a really kind of unique position working with this team. We help this team through the grant process, and I do sit on and make comments about outreach. Okay, let me tell you about PAPAS. This team is very innovative in a lot of different approaches, but it's actionable science against nematodes, and it's a team of scientists and researchers focused on addressing the industry-wide challenges in managing potato nematodes. The mission of PAPAS is to develop a systems approach to control plant-parasitic nematodes that threaten the potato industry in the United States. We're going to talk about the systems approach and how this team is attacking this problem in multiple ways. And then we'll, towards the tail end of this webinar, be talking about some of the outreach tactics that this group has used. So I'm going to start. I'm going to pass the ball to Louise Marie. And Louise Marie is really going to talk about the team, the objectives of the team, and why is this work important to the potato growers of America. So Louise Marie, I turn it over to you at this point in time.
Okay, thank you, John, for that introduction. I'm Louise Marie Dandrand. I'm a plant pathologist and nematologist at the University of Idaho, and I'm the project director for our systems approach to nematode control in U.S. potato, which we've dubbed as a name of a project as PAPAS, which means potato in Quechua and in Spanish. And this is quite a large team, a big multidisciplinary effort, has 6 institutions and 16 PIs total. So large project at tackling the problem of potato nematodes and making sure that we can come up with solutions for that. Well, we do want to talk a little bit about what the problem is, and we're tackling 2 different economically important nematode groups. First are the root knot nematodes, and here we have 2 different species of nematodes that are pretty critical for the potato industry. First is Meloidogyne chitwoodi, or the Columbia root knot nematode, and the other is Meloidogyne hapla, which is the northern root knot nematode, and they cause quite a bit of damage to potato tubers. Here I have a picture on the right showing infection of tubers by these root knot nematodes, and again, these tubers are unmarketable and undesirable, and if a shipment has if root knot nematodes are present in a shipment, especially the Columbia root knot nematode, then that shipment could be completely rejected. So quite a cost to the grower and to the potato industry. The other group of nematodes that we're interested in is potato cyst nematodes. And again, here we're tackling 2 different species, Globidera pallida, the pale cyst nematode, and Globidera rostockiensis, the golden nematode. Both of them are regulated quarantine pests in the United States. The golden nematode is found only in New York on a limited acreage in potato growing areas. And the pale cyst nematode is found only in the state of Idaho on about 3,000 acres, which represents about 1% of the potato growing area in all of the state. Again, a highly destructive pest of potato, and it is a regulated pest. So both of these, some of the commonalities that we're trying to address is the lack of resistance in potato. There are some resistant varieties to the golden nematode, but none to the pale cyst and none to the root knot nematode. And we're trying to develop those types of varieties. And this Joe Cool will talk about this shortly. We don't have very many damage thresholds either for these nematodes, and we're trying to develop decision support models for that. Diagnostic methods are pretty limited, especially when it comes to rapid techniques in the molecular area. And then, as everyone knows, there are fewer and fewer nematicides available out on the market to control these pests. And so we are trying to look at nematicidal chemistries to develop new chemistries for use as nematicides. As one grower has told us, the industry, they feel, is one disaster away from disaster. And so we're really trying to prevent that and come up with solutions for growers. For this particular project, the PAPAS project, working on development of decision support systems and understanding cropping systems that would control the nematode, as well as development of novel nematicidal compounds, along with helping to phenotype for resistance. And then, of course, doing an awful lot of outreach and relaying our message about the project to our stakeholders and growers. The best way to prevent an infestation is to prevent the problem in the first place. So if you don't have a nematode problem, make sure you don't introduce that problem into your field, and that would be through clean seed primarily. The project itself is to develop a systems approach for controlling nematodes of potato. In a systems approach, what we all recognize as scientists is that you need more than just one silver bullet to control nematodes. So if you were to apply a nematicide, certainly that will be effective, but not as effective as if you were to apply nematicides along with planting a resistant potato or other means of managing those nematodes.
If you get a nematode infestation in your field, how long is a potato grower going to have to deal with that?
Once you have an infestation, for the most part, the potato grower would have to deal with it forever. It is unlikely, it's very difficult to eradicate nematodes from fields. Of course, for the potato cyst nematodes, the strategy is eradication and very, very much trying to eradicate these nematodes from both New York and Idaho through use of fumigants. And for New York, primarily through use of resistant varieties.
Thank you, Louise Marie. Next, I'd like to introduce Philip Watson. He's a professor at the University of Idaho. And what Phil brings to life in this project is the economics of nematodes and what they represent as a cost to U.S. potato growers.
I'm Philip Watson. I'm a professor of agricultural economics here at the University of Idaho. And my part on this project is to kind of look at the economics of kind of nematode infestations. So kind of the first part of this project, we generate these enterprise budgets that track costs and earnings for different production regimes for 6 states for potato production for Idaho, Washington, Colorado, Wisconsin, North Dakota, and New York. Those states represent over 70% of total U.S. potato productions. Producing potatoes in those different states under 3 different production regimes, one being kind of fumigated, kind of more traditional nematode mitigation. Then we had developed kind of a non-fumigated budget, and then we developed a budget for nematode-resistant potato production, either existing nematode resistant varieties such as like King Russet or potential new varieties that are developed. So we have those built to look at kind of on-farm financial aspects of nematode infestations. And we also have econometric models, which are estimating kind of the supply and demand fundamentals for potatoes that allow us to look at kind of how, as prices change, how does consumer demand for potatoes change. And it also allows us to kind of do some financial analysis, some break-even prices, some sensitivity analysis to, how does either a specific input cost affect profitability, or how does price, how sensitive are our profits, our net returns to producers to output price or any of the specific input prices. That then allows us to calculate economic impacts, both for the farmers, but broader to the state's economy. So what would potential potato infestations cost in terms of state GDP, for example, or jobs and income, those kinds of measures. And nematicides, are roughly 20% of production costs. So it's a fairly substantial cost to control nematodes. We found basically that nematodes reduce farm gate revenues by between $332,000 per 100 acres up to $570,000 per 100 acre, depending on the state and which assumptions and production regimes we're talking about. Now this could, so if you have a nematode infestation, you could you have to take it out of potato production, but you could put it back into something like a cereal crop. So when we kind of add those back in, that those losses can be partially mitigated, but you don't make as much certainly per acre on cereals as you do on potatoes. So the net losses when you kind of allow for the substitution of crops, we're looking at between $290,000 to $500,000 per 100 acres. And then more broadly, when we take those numbers and kind of count for the input, the input suppliers, the household income that goes to restaurants, and when you kind of allow for those linkages in the state's economy, kind of the total impact on output of these nematode infestations be between 668,000 and 1.8 million per 100 acres. And then looking at kind of those different regimes, it certainly seems like the nematode resistant varieties make the most economic sense to kind of in the long run profitability for producers. Although there's still some uncertainty about those varieties as they're proprietary or kind of still in the development stage. So some uncertainty regarding licensing fees, things like that. These projects, to improve potato varieties or potato production regimes, I think we focus rightfully so on the fact that these are helping producers with their bottom line, both in the short run and the long run, and especially they help producers kind of in the short run with reducing costs or preventing outbreaks. But we can't forget the fact that the benefits of these projects really is also really helping consumers with a safe and affordable supply of high quality potatoes.
These teams typically have an economist involved because if you come up with a solution, it's not really actionable if it's not economic for the grower to implement. How do you do this? How do you look at that scenario where, a different strategy might be involved for nematode control for the grower?
So the first model we built was using the economic impact, was an economic impact model that used the enterprise budget data to kind of track as expenditures are made in the economy. So kind of what's next is we are building kind of what we call an econometric model, a statistical model that basically estimates simultaneously supply and demand for potatoes, because we want to get at some of the elasticity. So as the price of potatoes go up and down, that affects the quantity demanded. It's kind of a classic economic relationship. It's not just the farm gate that gets affected by nematodes. It's also the input suppliers to the farms. It's also the household income of farmers who then spend money on restaurants. So when you take into account all of those linkages, it's a broader economic impact, and we have models that do that. We'll have kind of these response coefficients. So if you look at kind of how much acreage is expected to be taken out of production in a specific area, we can calculate kind of a rough estimate of the economic impact of that. If someone wanted to ask the question, like, what would be the economic impact to Idaho of 3,000 acres potatoes taken out of production? I think that's something that we could train a model to, with the information it needs to answer that question.
Well, thank you, Phil, for that information. Now we're going to turn the discussion over to Inga Zazada, and she's going to tell us about improved diagnostics and decision support.
Thanks, John. First of all, I'd like to introduce myself. I'm Inga Zazada. I'm a research plant pathologist, nematologist with USDA ARS in Corvallis, Oregon. I've been working with nematodes for 20 plus years, and I want potato growers to know they're not alone. The challenge really is that we don't have a lot of methods to control nematodes. And really, for potato growers, their number one line of defense against nematodes are fumigant nematicides. These are very effective compounds, The problem is that they're expensive and availability is becoming unknown in many different agriculture sectors. What we're trying to achieve with Objective 1, which I'm the lead scientist on, really is to find a diversity of tactics that can be used to control nematodes that don't solely rely on these fumigant nematicides in the future. We have two sub-objectives within this objective. First is to develop new molecular DNA-based technologies for identifying nematodes, providing a more robust molecular diagnostic. And the second sub-objective is to use data and generate data so that growers can make decisions based upon information about damage potential of nematodes, biology of nematodes in potatoes. We hope to be able to reduce the risk of a grower having potatoes rejected for quality impacts due to nematodes. I'll give you an example. So the Columbia root knot nematode, which Louise Marie mentioned, can cause a tremendous amount of quality damage to potato even at low initial densities. What we hope to do through decision support is develop a more robust detection method for this nematode that will detect low levels using DNA from the nematode.
I think anybody that's been in the industry knows, how significant this problem is as a grower. What about the next generation of potato growers?
Yeah, I think the next generation of potato growers should be encouraged by what's going on. So let's couple the next generation potato grower with the next generation scientist. On this project, we have 5 to 6 graduate students involved in various objectives. Specifically for Objective 1, we have 2 master's students who are helping to develop molecular diagnostics, who are out working alongside potato growers to generate data for our decision support models. We also have quite a few young technicians on the project who are learning how to do science and how to interact with stakeholders and do on-farm research. And all of this will serve the future of the potato industry, regardless if you're working on nematodes or other issues for the industry.
So now I'm going to ask some questions to another team member, Joe Cool. And Joe, you work more on the breeding side of the equation here, because one of the strategies is to introduce a nematode-resistant, potato variety.
Right. Thank you, John. I'll briefly introduce myself. I'm Dr. Joe Cool. I'm a professor at the University of Idaho of plant genetics, and I focus on potato genetics in particular. I'm the lead PI for Objective 2, which, as John introduced, is focused on resistance to nematodes. We are focusing on new sources of resistance. One is a highly resistant plant called lychee tomato. We have another group of researchers that are focused on wild potato relatives and identifying new sources of resistance in those species. And then there's a third group of researchers that are focused on developing new potato varieties that are resistant to nematodes. And all three kind of work together to provide new options and opportunities for growers such that they can plant resistant varieties in their fields, and those resistant varieties can contribute to control and reduction of nematodes. To really do the job well and to assist with the breeding process, it is the most readily accessible if there is a molecular marker tagged to a single source of resistance. And so with that little molecular tag, you're able to track where that resistance is. Once identified, then it becomes a process of breeding, moving that resistance or the genetics for that resistance into those varieties that you want to release. The tags give you an idea that it might be present, but the real test is to challenge the plant material with the tag, with the nematodes, and show that the resistant is in fact present and active in that particular piece of germplasm.
So you've identified some genetics that could bring nematode resistance to a new variety. Um, how long does that take, and how do you integrate that into the breeding process for a breeder?
The new sources of resistance, it's always a bit of an unknown how long it will take to identify, and you want to look in a large number of varieties and species such that you increase your likelihood of finding something new. We're looking at resistances from all over the world and trying to move those into varieties that are suitable for the United States. We work really hard to identify these molecular tags so that we can efficiently move resistances into new germplasm for the breeding process. And when you release a new variety that encompasses resistance, it is truly a new variety. It must have the yield and quality attributes of any other new variety that's going to be released on the market. Typically, the breeding cycle, you're looking at 10, 15 years for a new variety to be released. I would say that is approximately the timeline for releasing new variety with the additional trait of being resistant to nematodes.
Okay. Thank you, Joe. Cynthia, this is my next team member to introduce. And Cynthia is going to talk about novel chemistries for nematode management. So, Cynthia, if you'd like to introduce that objective and tell us a little bit about yourself, please.
Yeah, thank you, John. I'm Cynthia Gleason. I'm an associate professor at Washington State University on the Pullman campus in the plant pathology department. And I consider myself a molecular nematologist. And I'm leading this Objective 3 novel nematicides. And this is a really interesting objective dealing with a plant called Solanum cisimbrifolium. Lychee tomato for short because, well, that Solanum cisimbrifolium is quite the mouthful. So it's lychee tomato. Lychee tomato is actually a wild relative of potato and tomato. It's very, very resistant to nematodes. It's resistant to root knot nematodes. It's resistant to cyst nematodes. The potato cyst nematode really does not like this plant. So we see that if you put nematodes onto lychee tomato roots, those nematodes die. So this gives us an indication that there's something toxic about lychee tomato. And so part of our objective and the scientists in this objective is to try to figure out, well, what are those toxins that are coming from lychee tomato that make it so effective? And so we're working with a soil biochemist to take lychee tomato and take those exudates that are coming from the roots that we can see are killing the nematode eggs and juveniles and trying to figure out what they are using various biochemistry techniques. So this is going to be a great tool for us to really understand how are they naturally resistant to nematodes. So at the moment, we are using various extraction techniques to figure out and narrow down more and more what is it that is toxic to nematodes. It could be one chemical, it could be multiple chemicals working as a cocktail together.
And then what would happen? I mean, long term, if you find the substance or the means by which a lychee tomato resists a nematode?
Yeah, that's a great question. The idea is that, there are fewer and fewer frontline synthetic nematicides that are available. And so we can try to use lychee tomato to inform us what is out there that's naturally occurring that is a nematicide. And so this is the sort of information that we could eventually give to companies that are interested in nematicide development.
Okay, now I'm going to speak about outreach. And there is a PI that's assigned to outreach, and that's Walter DeYoung. And Walter is an associate professor at Cornell University, and he really leads the outreach efforts on this project. These grants are more effective when there's communication done with the grower. And we talk about the next generation of scientists and how they're communicating to the next generation of growers. And this team, in my mind, exemplifies using innovative solutions and different ways of doing that. So there's a whole series of ways you see this done. There's a published annual report that this team has done that's available. Just published articles. Are they available? And what's the magnitude of them? How many comes out of a project like this?
Yes, we have a lot of articles that are published. Of course, we've sent things to industry journals. Our fact sheets are very informative about nematodes, about potato breeding. Our website is probably the most comprehensive place where information that we've put together is available. That we continue to add more information, diagnostic labs that are available. Once we have decision support models in place, we are going to develop workshops for that, and that will be available. Also, dates for that will be posted on our website. We want that to be out and used by the industry. And so do please check us out, potatonematodes.org.
You get out to state meetings? Is that part of this process?
Yes, we get out to, we've certainly been to the Idaho conferences, Oregon, Washington, New York. We've done some of the Midwest conferences as well. We plan to do Colorado next year. There's others that we haven't hit yet that we definitely want to have a presence at. Of course, all of us are very active as well in giving presentations and presenting at Potato Expo or many of the potato conferences that happen across the United States throughout the year. And so perhaps you have seen some of us there, and if you have not, we'll be there next year again. Right now, I'm hoping to roll out a diagnostic workshop on some of the techniques that we have been using and developing, molecular methods to determine different races of Milordigani chipwoodi as well as hapla, and different species of potato cyst nematodes. So hoping to do that as part of towards the end of the Potato Association of America meeting. We will have diagnostic workshop right after that meeting in Wisconsin.
Okay. And I understand this team is also putting together an email list of interested growers. Social media is part of this whole plan also, am I correct?
Yes, it is. Absolutely. And of course, if people are interested, we have a link here. Go ahead and sign up for our newsletters. Take a look at our website. Send us your email. We will definitely connect you with more information.
And a project like this has a lot of players and a lot of expertise that's brought into the equation. So I know you would like to introduce that team, and I know you also want to give credit to the funding source for this project. So I'll turn it over to you, Louise Marie.
Great. Here we are. This is the executive membership right here, the speaking, presenting this webinar. But each one of us leads a team of researchers and is quite a multidisciplinary team. We have principal investigators doing the bulk of the research. Alan Kaplan at the University of Idaho, he's a biochemist and molecular biologist, tackling some of the plant's defense genes, as well as working on Objective 3 with Cynthia to identify toxic metabolites from lychee tomato. We have Jonathan Whitworth, who is a potato breeder in Aberdeen, Idaho, working with Joe to help us develop resistant potatoes. We have Max Feldman, a potato geneticist in Prosser, Washington, also working on developing resistant potatoes to root knot nematodes. We have Ananth Kalyaranaman, who is over at Washington State University, and he's one of our big data scientists helping us develop our decision support models. Rich Novi has recently retired, but he's a potato breeder, very active in developing resistance in russet-type potatoes to the pale cyst nematode and other potato cyst nematodes. Ina Popova is our soil biochemist, analytical chemist, who is helping us identify compounds from lychee tomato that might actually have potential as nematicidal products. Segar Sathubali, he's a potato breeder at Oregon State University, working on root knot nematode resistance development. Rhett Spear is a potato scientist at the University of Idaho, and he's helping us with outreach, field trials, things like that. We have Zhahong Wang, who's a nematologist at USDA-ARS in Ithaca, New York, and she is really leading the efforts on identifying new genetics, novel sources of genetics from wild potato plants. We have Marisol Quintanilla from Michigan State University, again, very instrumental in outreach efforts for potato nematodes. And the last person, Pengming Zhao, is a plant pathologist, a molecular plant pathologist, helping us identify genes that are found in lychee tomato that might confer resistance. So this is overall our team. Again, we're from many different institutions here that are obvious on this slide. And I do want to acknowledge the Especially Crop Research Initiative program through USDA NIFA that has funded our project. And that's a $6.8 million grant, 4-year grant.
Recently, you met with your advisory panel. What was the purpose of that meeting, and how did you communicate results to your advisory committee?
So our advisory committee is made up of potato growers and industry representatives. We also have folks from academia. And the purpose of an advisory committee is to help direct our research efforts to best serve the potato industry. And so in these meetings, what we try to do is summarize what we've done in the previous year and present that to our advisory board. It's a give and take conversation. They'll hear what we've done and give us a pat on the back. But, they'll also suggest, other things that we need to pursue and tackle so that we can help the potato industry. So it's a very useful mechanism for our project, but also other SCRI projects to really address industry needs and priorities in a very quick and effective manner.
Yeah. I'm going to wrap this up. I'm going to commend this team. I always find it intriguing. It comes back to the systems approach idea. How can we as a team attack nematodes in multiple different ways, either through resistance or, nematicide that, is natural resistance, through a modeling system that lets a grower assess, what kind of risk they're at and adapt practices if necessary. Showing the economics of what does this represent, and how easy is it to make changes, or how costly is it? And because that's really important to put this in commercial terms to the grower. So I really want to commend the team for this kind of broad thinking about this problem and looking at solutions from multiple angles. And science advances when you've got a good team of people that run their ideas by each other and support each other and present their results so that they can gain some synergy in the process. So that's it for our webinar today, and I thank you to the listeners who were part of this today.